Hello everyone, and welcome to session 1 of this Elefront tutorial. In this first session, I will explain why Elefront is used and why you might want to use it. The range of uses for Elefront is quite broad. You can use it in your everyday life just to make working with Grasshopper a bit easier, or you can use it to its full extent on large projects. So here are some quick basics. Elefront is an add-on for Grasshopper, which in turn is a plugin for the 3D NURBS-based modeling platform Rhinoceros. As you are watching this video right now, it is assumed that you have proficient knowledge of both Rhinoceros and Grasshopper to continue. So now that we have that out of the way, let's see why anyone would want to use Elefront. As we all know, Grasshopper is a great tool for algorithmic design. It lets the user explore a multitude of shapes and allows variation of parameters to modify shapes that have been defined through linking so-called components. The principle is beautiful, and Grasshopper out of the box will enable the user to do this and explore many other uses for the Grasshopper platform. However, as with anything that runs on a computer, once your project reaches a certain scale, it becomes quite difficult to operate your model and its definition. Also, with all these design options and all these different parameters, your Rhino files can easily become overpopulated. Many projects, especially in architecture and construction, would like to be developed to a level of detail that simply no modeling software and hardware is able to process. On top of that, as the models grow in size, so do the Grasshopper definitions that created them. The larger the Grasshopper file, the harder it becomes to effectively manage it. So when dealing with incredibly large models and equally large Grasshopper definitions, you need a way to dissect the process. The way Grasshopper does this is by compartmentalizing each function in a node and have the user only deal with the inputs and the outputs. For instance, 1700 lines of XML code are represented by only a handful of components. Each component has a clear task, and all the user cares about is the result of that task. Produced outputs can again be used as inputs for the next tasks. In our process, we basically zoom out a step and consider a Grasshopper script to be one node in the graph. The outputs of the nodes are stored in a Rhino model, which can again be used as the input for the next Grasshopper node. Now, why is it so important to distribute the model over many smaller models? I will try to explain that. Each object can be represented in many different ways. Different trades need different aspects of an object. For architectural renderings, you'd want the models to have the most detailed geometry possible. Materials as well as textures need to be assigned. For basic indication of the object in space, you could do with a much lighter version of that model. In order to determine, for instance, sidelines from chairs, you only need access to the seating surface at the correct height. Some parties in the process just need to know properties of the object, such as dimensions. And for creating a 2D drawing, you need another representation. And a quantity surveyor only needs to know how many we need. So storing all of these representations into a single model means that everyone making use of this model needs to deal with way too much information and way too large models. In the Elefront process, each representation of an object can be stored in a separate model that is coordinated from a lower level model. The concept of algorithmically linking all models to one another makes for more flexible model updates. I hope this image explains the value of algorithmically driven processes as opposed to a manual approach. Simply adding a bunch of seats while maintaining all constraints of accessibility, seat rotation, and sidelines would completely disrupt this layout and would basically require remodeling the entire arrangement. But with algorithmically driven modeling, these changes can be made in a matter of minutes. So how does this work? The way we access the geometry in the Rhino models is by querying the geometry attributes. We basically call in geometry from the Rhino model by specific properties. This way we create a text-based binding that does not rely on the actual object. By saying that, I mean that the original object can be replaced at any time. As long as the attributes are assigned consistently, the new object will be recognized and processed accordingly. This is where Elefront comes in. The plugin allows us to assign these attributes to the Rhino geometry when baking from Grasshopper, as well as referencing the geometry back in from Rhino to Grasshopper. Each Rhino model is saved and can be used as input for the next Grasshopper definition that can dynamically reference Rhino geometry back into Grasshopper for the next step. The result is a network of models that each contain information about a specific part at a specific point in the process of the model generation. We call this a distributed data model. It consists of discrete sets of data that are stored in Rhino files and represented as attributed geometry. Each Grasshopper file in the network typically creates one type of object, and more specifically, one version of that object. As I will show later, it typically takes a few modeling steps to get to a specific representation of an object. By separating these steps out into individual models, anyone, at any time, can have access to each step of the generation process for each type of object in the model. Each task requires specific inputs to be able to generate the output. These inputs can now be mixed and matched from a myriad of models that all contain coordinated information. Using this principle, you can easily scale up your project, with the only limitation being disk space. Another huge benefit of this approach is the fact that each node in the model can be operated by a different person. It is now possible to collaborate on a Grasshopper-driven 3D modeling process with a large number of people and trades. As long as the attributes are assigned consistently and the Grasshopper scripts are robust, changes can be propagated without too much disruption to the project. In the design and construction industry, collaboration and data exchange between different trades and software has always been problematic. In most cases, it is possible to convert geometry from one platform to another. But most of the time, this means that any other data about the objects is lost. With the Elefront process, all objects are represented by some form of geometry and a large set of data. The instant accessibility of this data makes for flexible reformatting of the data. We are now able to communicate with different software platforms on a much lower level than with model file exchange. So now that we know the general idea, let's get our hands dirty and take this whole thing for a spin.